Hello everybody. So in today's video we'll be talking about one of the most commonly used application layer protocol, which is commonly used between client and server communication. Yes, HTTP. We'll be talking about its journey so far since its inception in 1991 and what are the improvements has been done since the first version, that is 0.9, till the latest version, that is 3. So without wasting any further time, let's jump to the video. Okay, so let's start with the first HTTP version, which was released way back in 1991, that is 0.9, which is obsolete in today's world, and that only supported the GET method. After 0.9, another version for HTTP was released in 1996, which was HTTP 1.0, and although this is also obsolete in today's world, but one of the disadvantages at that time was that it only allows one request per connection. To understand this limitation for HTTP 1.0, let's discuss about how exactly HTTP works. So now let's see how HTTP communication takes place between client and server. As part of any HTTP request, first client needs to establish a connection with the server. To establish a connection with the server, it's a three-way handshake process. First, the client sends a request, a SYN request to the server, and in response to that, server replies with a SYN acknowledgement. When client receives that acknowledgement, client again sends the acknowledgement back to the server that, hey, I have received this SYN acknowledgement. After completion of these three steps, we can safely say that connection has been established between the two parties. Now the client can send HTTP request for any resource access, and in response to that, server will reply with a HTTP response. Now after the completion of these two steps, the connection will be closed here. The client will not be able to send any further request to the server because as part of HTTP 1, we need to establish a connection per request. Obviously, this is very costly and resource consuming, but let's see how HTTP 1.1 resolve this issue. So we just saw what are the limitations with HTTP 1.0. Those limitations were mitigated as part of HTTP 1.1, which was introduced in 1997. It allows you to keep the connection alive until and unless it has been closed purposefully by the server or the client. So over the same connection, the client can send multiple requests to the server and can get the multiple response, obviously corresponding to those requests, back from the server. But yes, this also has some limitation. So let's discuss about it. So let's assume client has already made connection with the server using a three-way handshake process. Now as part of HTTP 1.1, client sent many requests over the same connection. Let's say it's the request 1 and again another request on the same connection, which is known as request 2. Server can take his time and send the response back to the client. Let's see, response 1 and response 2. So far so good, but here also we have a problem. We can send multiple requests and we can get multiple response over the same connection. But the concern here is that until and unless we get the response of request 1, we can't receive the response of request 2. This is known as commonly known as the head of line blocking, where if let's say request 1 is taking 3 seconds to process and request 2 is taking 1 second to process, assuming both these requests are going almost at the same time. So ideally, the response of request 2 should be received by the client first, right? But that is not going to happen. Thus, it will be in the sequence in which the request was sent to the server. So in this way, the request 2's response will be delivered after response 1, which is already 3 seconds delayed. So the response 2 time would be around response 2's actual time plus response 1 time, correct? Obviously there will be some kind of other additional factors too, which will be added to the total time, but ideally response 2 will be delayed because of the response 1. So that is the main problem with HTTP 1.1. Now let's see how HTTP 2 resolved this issue. So HTTP 2 was introduced in 2015, and it was mainly about solving the head of line blocking. So it introduced a new concept, which is multiplexing, which allows client to send multiple requests and to receive multiple response from the server over a same connection, and that connection is now known as the streams. So we have established a stream between the client and server, and the packets corresponding to the request and response can flow between these two parties in any order. They can be multiplexed between multiple requests. So let's see how exactly it works. We have established a connection between client and server. Now after establishing a connection, we have created a stream between the client and server here. This is the stream. Now as part of this stream, client can send multiple requests, and obviously those multiple requests are traveling as a packets between client and server. There are multiple packets which are flowing between the client and server. Similar to that, the client can receive multiple response packets back from the server. Though there is no requirement like these need to be in order, they can flow in any sequence. So that actually allows the multiplexing of multiple requests and multiplexing of multiple response using this stream. So far so good, but here also we have a problem. The problem is HTTP is the application layer protocol. These sequences will not matter for the HTTP layer, the application layer, but on the ground, that is at the transport layer, the TCP, which HTTP 2 is using behind the scene, actually requires that the packet should be in sequence. So what happens now? So let's assume that this packet, which is part of request 1's response, gets lost on the transit. So until and unless this request 1 packet will be delivered to the client, TCP will not receive the packet which is coming just after that request 1 packet, that is the response 2. So that way, this is again a head of line blocking, but now it's not on the HTTP layer, it's now on TCP layer. Because of this TCP or the transport layer protocol that we are using as part of HTTP 2, we are not able to process multiple responses out of the sequence. So HTTP 3 was recently introduced in 2022, and it's no more using TCP behind the scene, as TCP was causing the issue in HTTP 2 and it's not letting HTTP 2 to utilize its full capacity. So now as part of HTTP 3, that has been removed. Now we have QUIC that is established. QUIC is a new protocol that has been created over the UDP, and you might be aware that the TCP is a connection oriented protocol while UDP is not the connection oriented protocol. Okay, so let's first understand the stack difference between HTTP 3 and the earlier version of HTTP like 1.x and version 2. So earlier version were based upon TCP, and the latest version, the HTTP 3, is based upon UDP, which is not connection oriented. Over the top of UDP, HTTP 3 is using QUIC, which is basically provide the security by default in HTTP 3. So till now we have assumed only a three-way handshake to establish a connection between the client and server, right? Now let's say if we want to use the HTTPS, right, in that case we need to perform another handshake which is known as the TLS handshake, right? So let's say the three-way handshake for connection establishment and another three-way handshake for TLS. The total 6 number of steps need to be performed between the client and server in earlier version of HTTP. Now as part of HTTP 3, which is not based upon TCP, so there is a single step for connection establishment, which is a quick connect, right? And as part of this single step, we can do the connection establishment as well as it provides the security out of the box. You don't need to establish another security connection between client and server. As part of this response, we will get a connection established between client and server. Now after that, a client can usually send the request from client to server and can get the response from the server. And remember, these requests and response are in packets. So now these request and response packets can travel out of the sequence between client and server. There is no such restriction as we used to have in TCP. Okay, so now because of this, HTTP 3 performance is quite better compared to the earlier version of HTTP 2. It has certain disadvantages as of now because it is not yet adopted in many of the organizations. But yeah, in future when this will be a common practice, it will obviously give a very good performance result as compared to the other earlier versions of HTTP. Okay, so that's all from my side. I hope you like the video. Have a good day. Bye.